and then some people have never ever seen. So forgive me, I'm gonna try and go super basic and explain all the parts of the box plot. If you've seen it before, you're probably like, yes, we don't need it quite so in detail, but I want to go through it just so people know exactly what each part of a box plot is. So box plot, another thing we could call this is a box and whisker plot. Here's the box. And then if you think of like a kitty cat, they're calling these things the whiskers on the end of it. We don't always call it a box and whisker plot. Box plot is the same thing, okay? This is sort of like a super standard way of summarizing a bunch of data. And what it's trying to do is break things up into quarters for you. So when you're looking at a box plot, some important things. These two endpoints here. Those are called the extreme values, or they could be called the endpoints. They could be called the lowest point or the highest point. If I'm looking at this data right now, what's my lowest point on this particular graph? 2. So 2 is my lowest extreme. And in terms of what this is supposed to be, days of rain or snow. So this says the least number of days it rained or snowed in a month was 2. Okay. The most number of days that it snowed in a month was what? 10. And that's this point right here. So this endpoint right here is the lowest point. This endpoint right here is the highest point. Those are going to be your extreme values on a box plot. Okay. The median gets denoted by this cute line in the box. It doesn't have to be in the middle of the box. Like you'll notice in this one, it's not down the middle of the box. Sometimes it is, sometimes it's not. If it's down the middle of the box, it's telling you that your data is more symmetrical. And if it's not in the middle of the box, it's telling you your data is skewed either to the right or to the left. In this case, we've got our median of the data is skewed more toward the right-hand side than it is toward the left-hand side this time. But it could be over here in some other data that we look at. Could be right in the middle of the box. Okay. The median always tells us where half of the data is smaller than it and half of the data is bigger than it. So on this side of that line, we have 50% of the data. And on this side of that line, we have 50% of the data. The data clusters are always going to be kind of distinguished by the whisker, and then where the whisker hits the edge of the box, then the edge of this box to the median, yes, then the median to the other end of the box, and then the other end of the box to your greatest value. Each of these represents 25% of the data. So for this whisker right here, just hitting to the edge of that box, 25% of the data is between 2 and 3. Okay. 25% more of the data is between 3 and 6. 25% more of the data is between 6 and 7. And then the last 25% of the data is from 7 to 10. So that means when you're only seeing like between 6 and 7, that means there's a bunch of numbers here between 6 and 7 that are part of the data, even though you can't see them all. So what this does is it summarizes the data. It doesn't show you all the data points you have. It shows you your lowest data point, shows you your highest data point. It shows you where the middle of your data should be. And then it breaks things up into 25% groups. Okay. So if you had to make an actual box and whisker plot for yourself, these have the steps written down. You would order the data from least to greatest, and you'd find the median. And then you'd find the upper and the lower quartiles. So you'd find the Q1 and you'd find the Q3. We did those on Thursday when we found our percentiles. If I want the lower quartile, I'd find the 25th percentile. And if I want the upper quartile, that's quartile 3, I'd find the 75th percentile. So we'd use that formula that we used last time to go find those numbers. You'd find the extreme values. So you'd find the smallest value and you'd find the biggest value. And those would be your endpoints. And you'd go ahead and just put those on your graph and you'd know that those would be the edges of your whiskers. You would plot a point at the median and you'd go ahead and then draw a line through that median. And you'd put a point at the upper quartile, the lower quartile, and your extremes. And you're going to draw a box around the lower quartile and the upper quartiles as the sides of the box. And then you'll put your whiskers on the edges. And finally, you'll draw a horizontal line. I kind of already said the horizontal line part, but that'll go through your median on the data. Okay. Oh, sorry, that's a vertical line. Jen's saying that backwards. Sorry. Draw a horizontal line from the lower extreme to the lower quartile. Draw another horizontal line from the upper quartile to the upper extreme. Those are the whiskers. The horizontal lines are your whiskers. Okay. So that would be steps if you had to make one. Okay. We don't have to actually make one, but we have to figure out what those values are. That would be the next page. We've already got a picture drawn for us, so we don't actually have to make one. I'm going to pass around the sign-in sheet. If you're enrolled in the class, you're on the front page. If you're not enrolled in the class, just go ahead and put your name on the back page. Okay. The following data are the heights of 40 students in a statistics class. Okay. We already have them ordered from least to greatest. That's the good news, because if there's 40 data points, you don't want to have to put those in order from least to greatest by hand. That would be crazy. You'd be writing a whole bunch of things and crossing them out and be like, did I miss any? We have them in order already. All right. We need to find the minimum value. What are you going to tell me is the minimum value? 59. Because they're already in order from the smallest to the biggest, that's good news. Our lower extreme is 59. What's my maximum value? 77. Perfect. Don't we wish that all of our test questions were this easy? Like, I can find the smallest number and the biggest number. I'm prepared for that part. Okay. Little bit harder. Q1, Q2, and Q3. Okay. This will give us some practice from last time. Let's go ahead and find the median first. If we have 40 data points, that means we have an even number of data points, right? So I don't have an exact middle number. The time that you're going to have an exact middle number is if you have an odd number. So like, let's say you had 5. If you have 5, the middle number would be my middle finger, right? And you have 2 on this side and you have 2 on this side. When you have an odd number, you have an exact middle number. When there's an even number, you have 2 middle numbers and you have to add them up and divide by 2 to go find your median. So for us, if I have 40 students here, what numbers do I have to add up and divide by 2? We want to think of positions. So someone wrote this in their questions. They're like, Jen, I don't know what they mean by positions when we're doing these problems and we're finding quartiles and percentiles and that kind of stuff. When I want to find the position for the thing, that was when we used that formula that had the K's and stuff in it. Do you remember what the formula was? It was K over what? 100. Perfect. And then I had to multiply by something. You remember what it was? N plus 1. Nicely done. And if we did that, what it gave us was the position of whatever it is we were looking for in terms of the kth percentile. If I want the median, what percentile am I looking for? 50th. Good. The median is the 50th percentile. So if I'm trying to find my median, I'm going to do 50 over 100. What's the N? 40. N is referring to how many things are we talking about? We're talking about 40 students. So we're going to put 40 in there plus 1. Okay. And so if we do that, 50 over 100 is the same thing as 1/2, and 40 plus 1 is 41, right? So this is saying what's 41 divided by 2? Can we do that one in our head? 20.5. Perfect. When we got a number that wasn't a whole number, what we did is we took the whole number that was below this decimal number, 20, and then we took the one that's above that decimal number, 21. So that means we need to count over to number 20 and count over to number 21. And those are the positions for the things that we're going to use. We're going to add them up and divide by 2. So I'm going to start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to take 66 and I'm going to take 21, which is also 66. If I have to take 66 and add it to 66 and divide by 2, what am I going to get? 66. So that one's not going to be too bad. Okay. So when we do this, our positions were 20 and 21. I got 66 and I got 66. I'm adding them up and I'm dividing by 2, but 66 is going to pop out. So my median is going to be 66. We do exactly the same thing to find the first quartile and the third quartile, but we change out the percentile. So instead of using 50, I'm going to use 25 for the first quartile, and I'm going to use 75 for the third quartile, but we're going to do the same practice to do it, okay? So I'll do the 25 over 100. That's going to be my Q1 position. So that's position. Okay. It's still going to be 40 plus 1. So 25 over 100 is 1/4 times 41. So that's asking us what's 41 divided by 4. This one's a little bit harder. It's going to be, if it was just 40 divided by 4, you'd say what? 10. And then if we have 1 divided by 4, that's 1/4. So that's 0.25. So 10.25 is the number we're going to get. So that means that I need the position 10 and the position 11. And we're going to take those two things, we're going to add them up and divide by 2. So position 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 64. And 11 is 65. So I'm going to take 64 plus 65. And then we're going to divide that by 2. 64 plus 65, you actually don't need to do this calculation. If I'm dividing by 2, I'm asking you what's exactly in the middle of 64 and 65. Beautiful, 64.5. So you don't actually have to go do the crazy calculation. So my first quartile is going to be 64.5. Okay. To do the position for Q3 then, I'll do this down here. Position for Q3, we're going to take 75 over 100 and multiply that by 40 plus 1. 75 over 100, that's just 3/4 times 41. This one comes out to be a little crazier. So 3 times 41 is 123 divided by 4. I won't make you do that in your head. That's 30.75. So that's the position for Q3. So that means I need to go to position 30 and position 31. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I got 70. And 31, I also got 70. So 70 plus 70 divided by 2 is going to pop out a 70 for us. Okay. So oop, I didn't mean to circle the 20.5. I meant to circle the 66. Forgive me. I didn't look down. There we go. Okay. So let's see how we did because we actually already have a picture here. I cheated. We're doing this backwards. Normally you'd find these numbers and then you'd create the box plot, but we actually already have the box plot. We're just going to match up all the stuff. So we said that the smallest value should be 59. 59. Sweet, we did it. Okay. We said the biggest value should be 77. Sweet. we said that our Q1 should be 64.5. That should be the edge of this box. And it's at 64.5, nicely done. We said that our median should be 66, that's the line right here. Perfect, we got a 66. And then we said that our biggest one, our third quartile should be 70. And so that was the edge of the box right there. We did a nice job. Good work, people. That's what a box plot is, okay? We're gonna use this box plot now to answer some of these questions. These are like good quiz type questions, all right? Each quartile in this box plot has approximately what percent of the data? Beautiful. That is the definition of a quartile. So 25% of the data. Here's another vocabulary word. What is the range of this data? What does range mean? The highest number minus the lowest number, or the biggest number minus the smallest number. So we would do 77 minus 59. Okay, and 77 minus 59, what do we get? Yes, nicely done. So our range would be 18. Okay, interquartile range, that is the Q3 minus the Q1. So we said our Q3 was 70. Minus our Q1, we said was 64.5. So 70 minus 64.5. Did you get 5.5? Maybe kind of, sort of. Yeah. All right, 5.5 is our interquartile range. Okay, a little bit more critical thinking here. So let me make it so we can still see the box. What percent of the data lies between 66 and 70? Perfect, 25% of the data. All right, slightly more challenging. What percent of the data lies between 59 and 70? Perfect, 75%. So if you're wondering how they did that, each section of a box plot represents 25% of the data. So this is 25%, here to here is 25%, here to here is 25%, and then that last whisker is also 25%. So for the first one, between 66 and 70, that has to be 25% because that's just one section. And then if we want 59 to 70, we actually have 1, 2, 3 sections represented there. And so it's 25% in each of them. So this would be 25, then this would be 50, then this would be 75. Good job. Feel better about box plots? Okay. Next thing I got, sigma notation. Summation notation is another way we say that. Anybody taking calculus? You've seen summation notation or sigma notation in calculus. If you haven't, I actually don't know if you've ever seen this before. So it's gonna look scary if you've never seen it before. Don't be scared. I promise, I'll explain it slowly. I'll explain it as though you've never seen it before. Everyone get one? Okay. How many people hate math? I'm gonna put 2 hands up because I put myself in that category. Hate math. When I say that, you're probably like, yeah, that doesn't make any sense because here you are teaching it. When you first see stuff like this, if your heart rate goes up or you immediately go, I don't think I can do that, you might have something called math anxiety. It's a very real thing. Regular anxiety, people can have to social situations. You can have anxiety over, like, some people don't like to leave their house. Some people have a really hard time being in like big groups of other people and that kind of stuff. Math anxiety is actually a completely separate form of anxiety. So even if you don't have the other kinds of anxiety, you could have math anxiety. And they've done a lot of research where they've actually shown that it is totally happening in a part of your brain, a thing you cannot control unless you actively know that you have math anxiety and you're using techniques to try and control it. So what they've done is they've put people in what they call fMRI scanners. They're MRI machines, but they actually like hook people up to a thing so that they can see the activity in the brain at the same time. And they show that people who have math anxiety, if you show them math problems while they're laying in the tube, the scanner tube, the part of their brain that is the same part of the brain that lights up when you actually get hurt, like if someone were to like smash your hand with a hammer or something like that, the same part of your brain lights up if you have math anxiety. And people who don't have math anxiety, if they put they flash stuff in front of them, that part of their brain doesn't light up. The problem with people who have math anxiety is that when you see a new set of math problems, you go into shutdown mode. And you literally have to like talk yourself out of it and be like, breathing exercises for real. You have to relax a little bit because otherwise, like, you're basically, when you see something new, you're like, your brain is like, I have to protect myself from this terrible thing. And we actually have to try and calm and relax into it because the only way to get over the math anxiety is to work through the math anxiety. So when you're seeing these symbols on here and it looks scary and you're like, what the heck is that? And why are there numbers all over it? This sigma, that sign is a Greek letter. Its name is sigma. So when it says sigma notation, another name for sigma notation is summation notation. Which might not feel any better because you're like, that still sounds like a scary word, but I'm going to underline the first three letters, sum. Do you remember from your elementary school years what a sum is? The answer to an addition problem. So summation notation means you're going to add some stuff. So deep breath, adding's not bad. We can add. Adding's good, okay? The summation notation is telling us we're going to add up more than one thing. So it's just a fancy way of us saying we're going to add more than one thing. We're being lazy. Mathematicians are lazy by nature. They don't like having to write everything out. So when they write summation notation, they're doing it so they don't have to write out exactly, I want you to add up this and this and this and this. They're being lazy. So this first one, which I know is super tiny here, so I'm going to see if I can make it look any bigger. That's a little better. Okay. This down here says I equals 1. The number at the bottom of the sigma is telling us what we're going to start with. So it's saying start with 1. And the number at the top says what you're going to end at. And it's saying stop at 4. And these are actually positions. So if you look at these little X's up here, back in algebra, we would call something X and then maybe we'd call another thing Y and then we'd call another thing Z. We'd give them separate letters. In statistics, they actually typically try and use the same variable a bunch and they just stick little numbers after them to say, I mean the next one. So X1 is a different variable than X2, which is a different variable than X3, which is a different variable than X4. And these just say, I'm talking about the first X. I'm talking about the second X. I'm talking about the third X. I'm talking about the fourth X. So this little 1 through 4 is the position. And they're saying which X. Start with the first X, end with the fourth X. That's all that means. And it's saying you're going to take each of those 4 X's and you're going to multiply them by 2. So having that 2 sitting in front of the X thing there just says multiply by 2 because they're right next to each other. And when things are stuck together like that with no sign in between, it means multiply. So literally what this is asking us to do is take that first X value and multiply it by 2. So I'm going to take 2 times that first X value, which also happens to be 2. And because this is summation notation, we're going to put a plus sign now. And now it says, I want you to take the second one because we're starting at 1. I just used the first one. Now we're going to do the second one. Here's my second one. You're going to multiply that by 2 as well. So we're going to do 2 times the second one, which is 3. And then because this is summation notation, we're going to put a plus sign down. And then it says we're going to do the third one, which is -2. And we're going to multiply it by 2 as well. So 2 times that -2. And then because it's summation notation, we're going to do the fourth one now. And the fourth one is 1. So we're going to do 2 times 1. It said start at the first one and end at the fourth one. We started at the first one and we ended at the fourth one. So we did all the ones we're supposed to do. And what we did is we took all 4 of those numbers and we multiplied each of them by 2. So we followed the rule that it's showing there. And now actually all we have to do is the math part. So 2 times 2 is 4 here. 2 times 3 is 6. 2 times -2 is -4. And 2 times 1 is 2. This 4 and this -4 are going to cancel out, so those are gone. So I have 6 plus 2 more. And you're done. And you're like, Jen, that wasn't simple. That was a lot. And I'm like, I know, we're going to do another one, I promise. The first one you see is like, yes.
I just have a question on how you knew like which eggs were supposed to be there that you were supposed to
Mm-hmm. It says start at the first one, end at the fourth one. So because it has a 1 at the bottom, that means start with number 1. So I started with number 1. And then it says end at the fourth one. But the next one we're going to do, it says start at the first one and end at the third one. So we're not going to do as many the second time through. Okay? The X's are given to us. X1 is the 2. So that's why we put that 2 there.
But are they usually like the use X1 plus 2? Are those usually given to us?
They're usually given to you. Yep. Yep. Good question. They are usually given to you. If they're not given to you in calculus is usually where they're not given to you. They'll give you a formula for you to calculate them. In statistics, they're normally given to you. Okay. I'm going to do the next one. If you've only seen one, it's still confusing, I promise. You're not doing anything wrong. It's supposed to still be confusing. Okay. This one says we're going to start at the first one. We're going to end at the third one. We're still using the same X values, which are hard to see now. So I'm going to write them down again so that I can see them better. My X2 is 3. My X3 is -2. And my X4 is 1. Okay, so we're going to use those 4 X's. And actually, we're not going to use all 4 of them. I already know they're telling me to stop at the third one. So I'm not going to end up using that one. There's nothing wrong with leaving that up there as the list. I'm just going to say we're not going to end up using that one because it's saying we're only going to go from 1 up to 3 for this one. Okay. So now the rule says we're going to be adding things together. That's what the sum thing says. But the rule for this one doesn't say multiply by 2. It says take whatever the X value is and subtract 4 from it. So our first X value is 2. And you're going to subtract 4 from it. And so for me to just notate that that was me doing one of them, I'm going to put parentheses around it. And then because it's a summation, we're going to put a plus sign. We just took care of the first one. Now I'm going to do the second one. So I'm going to go to my second X value. It's a 3. And the rule says subtract 4 from it. So I'm going to write 3 minus 4. And then now because it's a summation, I'm going to put a plus sign. And then the rule says after we do 1 and 2, we're going to go up to 3. That's going to be the last one that we do. The third one is -2. And the rule says subtract 4 from it. Boom. We stopped at the third one. So here was our first X. We subtracted 4 from it. Here was our second X. We subtracted 4 from it. Here was our third X. We subtracted 4 from it. We followed the rule. Now we just have to do the math. So 2 minus 4 is -2 plus 3 minus 4 is -1 plus -2 minus 4 is -6. So I lost $2 and I lost another $1, so I've lost $3 now. And then I lost $6 more, so I lost $9 total. Why did I say dollars? I have a way easier time combining negative things if I think of money. So I usually say dollars, even though I know it wasn't really money in this problem, but that's how I think about the negatives. Okay. There was parentheses in this problem. Look at number 3, and do you see how similar these look? They're actually not the same. The difference between that one having parentheses and this one not having parentheses is this actually doesn't want you to take each value and subtract 4 from each value. What it wants you to do is ignore this right now. And it wants you to sum up all the x's. And after you do that, as the very last step, they want you to subtract 4 from your answer. The parentheses on this one says every single x, subtract 4 from every single x. But this one actually says, nope, just add up all the x's, and as your very last step, subtract 4 from your answer. That can be confusing. So what we're going to do is we're going to ignore that -4 for a little bit. This just says, I want you to start with the first x and end with the third x. And when it just has the x sitting right there, it literally just means add up those x's. How do I know it means add up those x's? Because it's summation notation, and summation notation means add. So if they just put an x there, it means add them. So our x's, again, we can't see them because they're up too high. I'm going to put x1 is 2, x2 is 3, x3 is -2, and we also had an x4, but we're not going to use it, so I won't write it again. Okay, so what this one wants us to do is take 2 plus 3 plus -2. Those are the x values. I took the 2, I took the 3, I took the -2. We're going to add those up, and then at the end, I'm going to subtract 4. So 5 minus 2 is just 3. And 3 minus 4 would be -1. Let me write my x's again. x1 is 2. x2 is 3. x3 is -2. Okay. What's this next one want us to do? What's the rule telling us? It's saying you're going to raise each of those x's to the second power. So each of those x's, I mean, you're going to raise that to the second power, you're going to raise that to the second power, and you're going to raise that to the second power. And we're going to add them all up because that's a summation notation and it always means add up. So when we have this, the rule says square each of those numbers or raise them to the second power. So we are going to take 2 squared plus 3 squared plus -2 squared. So we literally took all of the x's and we're squaring them. And then because it's summation notation, we got to put plus signs. So 2 squared is 4, 3 squared is 9, -2 squared is also 4. So we got 13 plus 4 more, 17. Okay. Last one. What's the last one asking us to do? Because they put the parentheses around this thing instead. square the summation, and you actually already did the summation earlier. If we go back up, you did your summation of those things. If we just leave off that -4, it was that number plus that number plus that number. It just came out to be 3. But I'll write it out down here so you can see it. So what this says is you're going to add up the x's, and then we're going to square our answer. So by putting the parentheses around the whole thing and then putting the squared on the outside of that, they're saying add them up first, square your answer. So when we add them up first, we have 2 plus 3 plus -2. And once we get that answer, we're going to square it. So the 2 and the -2 cancel, so we just get 3 squared, which is 9. Yay, you survived summation notation. Questions on any of these?
It sounds like not correct notation if I was to like parentheses in the 3 square.
If you put parentheses like that, you'd be fine. Still good.
So the only way we would ever square the entire summation is when it has the parentheses on the outside, right? Like that's the only way
That you would do the whole thing, and then they're putting the squared on the outside of those, then you would say, okay, do all the adding first, then squared last. Yeah. So you'll notice that, again, these things look super similar to each other, but because this one didn't have the parentheses, this one actually meant square the numbers first, then add them up. So that's why we did 2 squared and 3 squared and -2 squared. Yep. I picked these ones on purpose because the parentheses like super change what we do. So you'll have something to look back on if you're like, what? If you're still feeling a little lost on these, that's normal. If you've never seen summation notation before, they're hecka scary looking. So my sister has a PhD from Yale. She's super smart, but her PhD from Yale is in history. So I sometimes like run some of my statistics stuff by her. And when she sees this type of notation, she goes like, oh, and that's how I know like just the symbols of it all must be what's scary, because she's super smart. So I know it has nothing to do with her ability to do a thing, but because she's like, she's got the math anxiety real bad. People who see that notation, if you haven't seen it before, it looks really scary. So it takes a little getting used to. It's okay. If you have more questions on it later, I'm happy to help. I promise the next part's not quite so bad. Stem and leaf plot. Did you do stem and leaf plots in high school? I had never seen one until I got to college, but some people were like, oh yeah, we did a bunch of stem and leaf plots in high school. Oh, okay. Stem and leaf plots are, again, lazy ways of writing a bunch of data. It's actually kind of funny. The stem, in this case, is your tens digit, and then each leaf is your ones digit. So if I wanted you to write out the list of the data, what you're actually going to write is 20, 20, 21, 22, 25, and 27. Those are our first 6 numbers in the list. Okay? If I have to write down the next 3 numbers in the list, what am I going to write? 38. You got it. So that's what we're going to do. You're just taking the stem and you're sticking the leaf on the end of it. That's going to make our number. So we're going to write out our list of data. So my data is 20, 20, 21, 22, 25, 27, 31, 34, 38, 42, 58, and 59. So it's not terrible. It's just, it looks a little weird if you've never seen one before. And then the question says, find the mean, the median, and the mode of this data. Okay. So this is just like what we already did when we did the percentile stuff. We should figure out how many of these numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 of them. So we have an even number. So because we have an even number, the median's not going to be the exact middle number. It's going to be the two middle numbers. And then we're going to divide by 2. So 12 of them halfway through would be 6. So we need number 6 and we need number 7. So 1, 2, 3, 4, 5, and 6 would be here, and number 7 would be here. So we're going to take 27 plus 31. We're going to divide by 2. So 27 plus 31. Yeah. So what we could have used is the formula that we did where we took the kth percentile and we divided by 100. I was sort of skipping through because I knew that there's 12 numbers here. Half of 12 is 6. And because there's an even number of numbers, it can't be the 6th number. It has to be the 6th and the 7th number together. But we could do the kth thing if we did. I'll come up here to show you. We said it's k over 100 times n plus 1. If we're doing the median, the k is 50 then. And then the n is 12 because there's 12 of these total. So this is going to be 1/2 times 13, which is 13 divided by 2, which gave us 6.5. That's the position. So this formula always gives us the position. So we need the 6th data value and we need the 7th data value. So I counted over 1, 2, 3, 4, 5, 6 is the 27 and 7 is the 31. So we're using those two, adding them up and dividing by 2. Good question. If we do that, we get 58 divided by 2. And 58 divided by 2 is going to give you 29. So our median is 29. Whoops. What is the median again? The median is the value where 50% of the data is below it and 50% of the data is above it. And it actually doesn't have to be a number in the list. Is 29 actually on our list? No. But 29, if it were on our list, half of the numbers would be below 29 and half of the numbers would be above 29. So 29 would go right here. 1, 2, 3, 4, 5, 6 of them would be below it. And if 29 is right here, 1, 2, 3, 4, 5, 6 of them would be above it. Half would be below, half would be above. That's always the definition of the median, that half the data has to be below it and half the data has to be above it. Is that okay? How is that different from the mean? The mean is the way we use average in everyday life. Yes. When we say average in everyday life, we mean add up all the numbers and divide by the number of numbers, right? So for the mean, you're literally going to have to do 20 plus 20 plus 21 plus 22 plus 25 plus 27 plus 31 plus 34 plus 38 plus 42 plus 58 plus 59. And then what am I going to divide by? 12, because there were 12 of them. assuming I didn't accidentally mess anything up, that was 397 in the top divided by 12, which is 33.08. I went out to 2 decimal places like that. If she's gonna give you answer choices, she's probably gonna give you 1 decimal place because she said go 1 more decimal place than the number of decimal places that are actually in the values, right? So the values themselves don't have any decimal places, so 1 more decimal place would be 1 decimal. So we would take this 8 and we would round up. So I would say that this was 33.1 would be my mean. So median's 29. Mean is 33.1. And then what's the mode? What's the word mode mean? The most frequent number. So on our list, which number appears the most times? 20. So our mode is going to be 20. Good job. All right, I'm going to tell you a thing that's going to blow your mind. All 3 of these are called an average. If you say, what's the average of this data? You could say 20 and you'd be right. If you said, what's the average of this data? You could say 33.1 and more people would agree with you because they'd go, yeah, that's what I think the average is. But you could also say it's 29 and you'd still be right because the word average in statistics is confusing. The word average in English, it means this one. Add up all the numbers and divide by the number of numbers. In statistics, we talk about something called measures of central tendency. I don't know if she's used that phrase yet, but measures of central tendency have to do with the way that we draw those distributions in a stats class. Does that look like a familiar shape? That's called a bell curve. But when we look at the curves like that, if I ask you where's the center of the data is in here somewhere. And the center of the data, I could be asking you for the mean, I could be asking you for the median, I could be asking you for the mode, I could be asking you for all 3. So the word average is complicated. When people say, oh, what's the average of the data? I usually look at them and I go, are you a stats person? And if they say no, I go, okay, cool, then I know what you want. I know you want this one. If you're a stats person, I go, are you trying to trick me? Because you could be meaning any of them. So average is weird in statistics. Could be any 3 of those. But fancy thing that we say is that all 3 of these are measures of central tendency. So I'll write that out. Mean, median, and mode are all measures of central tendency. We could really call any of them an average. I'm going to put that in parentheses. Because that's really weird. It's not how we use the word average in just everyday life. But we could mean the mean, we could mean the median, we could mean the mode. Why do these different things exist? They exist because sometimes the regular average isn't really the number that's most helpful to us. So if I'm thinking about times where I really care about a median, I should probably grab paper because I was about to put it on the board and then I keep forgetting my online people are like, we can't see the board, Jen. I'll grab paper. Do you think students make a lot of money? If I said, I think the average student salary at UC Davis is what would be a reasonable number for average student salary? Let's just say hourly instead of like over the course of the year. What do you think the average student salary for an hour is at UC Davis? I'm hearing 15, 16, 17, maybe 18. Average student salary is going to be somewhere in that range if we're using the word average the way that we normally mean it in English, right? What if I told you that Bill Gates's grandson is here on campus? He's not, but what if we were pretending that Bill Gates's grandson is a student here at UC Davis and he works for his grandfather? Okay, here's the problem. When we take an average, I'm adding up all the students. So maybe I ask each of you in here how much you make. And maybe one of you says, Jen, I make $17 an hour. And then I'm like, how much do you make an hour? And you're like, Jen, I make $18 an hour. And I'm like, awesome. And then I go around the room and then like we get like a 16 and we get another 17. And then maybe someone even says 20 and we're all like, ooh, 20. But if I stop here with 5 students and I wanted to take an average, I would just add up those 5 students, right? So I would say 17 plus 18 plus 16 plus 17 plus 20. And I get 88 when I do that. And I would divide by the 5 that are there. And that's going to give me what we consider what we normally call an average. And that would be $17.60. Does that seem like a pretty good, like general statement for how much students would make based on the 5 that we've tallied there? Okay, now here's another thing I could have done. I could have listed these from least to greatest. So I could put the 16 first, and then the 17, and then we had another 17. And then we have an 18, and then 20 was the biggest. If I put them from least to greatest, what's the median here? Because there's 5 of them, the median's the exact middle number. And so it's going to be that 17 right there, right? So my median would actually be a little bit lower than my mean, but it'd be pretty close. There's not a huge difference between $17 an hour and $17.60, right? They're pretty close. So my mean is this one, and my median is this one. And so in this particular case, it doesn't really matter which one I use to say what the average is. If you said that the average salary was 17 bucks an hour, people would go, yeah, okay, it's close. And if I said that the average was $17.60, you'd go, yeah, okay, that makes sense. Okay, Bill Gates' grandson, though, he's working for his grandpa. And so he's going to make $2,000 an hour. Okay, so we've got these same people plus Bill Gates' grandson. So when we added up the other ones, it was 88. Plus, and then he's making $2,000 an hour. Okay, now we're dividing by the 5 that we already had plus Bill Gates' grandson. He'd be number 6, right? So this is going to be 2,088 divided by 6. Okay, now our mean salary is 348. So if I ask you, what's the mean salary for UC Davis students, and we include Bill Gates' grandson, now it's $348 an hour. And so when I walk around and I say, UC Davis students make an average of $348 an hour, you all go, like hell they do. But we'd actually be correct if we're using the average the way we normally know average, right? But if I were to list these from least to greatest again, so I've pretty much already got the list I'm going to use, but we're just going to add Bill Gates' grandson to the end of this list over here. We're going to add the 2,000. If I ask you for the median now there's 6 numbers, so we got to do the 2 middle numbers, right? So my 2 middle numbers are these ones. What's exactly in the middle of 17 and 18? $17.50, right? So now our mean was $348, but our median is $17.50. In this case, if I asked you for the average salary of a UC Davis student, should you give me the median or should you give me the mean? You should give me the median. We do this a lot with housing prices. When people say the average housing prices in Davis, they're going to give you the median housing price because there's always those millionaires living in town. And they throw off everybody's data. And so if we throw in those crazy millionaires' housing prices and you say the average house price in Davis is, you know, $4.8 million, and people are like, what? And you're like, well, no, it's there's these rich people over here that are making it seem like you can't afford to live here. Now, Davis actually is a really expensive place to live, but like in general, it's not that bad to find a house in Davis. They're not that expensive. We got to get rid of those crazy high numbers. And then in that case, that's when the median is the better value. So that's why they want you to learn the mean, the median, and the mode, because sometimes when we're going to report out data, it doesn't really make sense to report out the mean. Saying the average amount of money that a UC Davis student makes per hour is $348. It's going to give the wrong idea to people. They're going to be like, UC Davis students are spoiled. They make a ton of money. And be like, no, one of them does. One of them is very spoiled. And then the others in general are making somewhere around minimum wage. So we shouldn't be judging them based on that. So that's why we need to know the difference between those things. Okay, last thing I'm going to do today. She had a slide on this. I don't know if she got to it. Did she do calculating the mean of a group frequency table yet? It had a scary looking formula. It had that summation notation actually in the scary looking formula, and it had an F in it and all that other kind of stuff. Basically, if you've got a mean of a group frequency table, the mean means you want to add up all the numbers and divide by the number of numbers, right? Well, that's tricky when we're doing a frequency table, because what that means is for, like, let's say that these were scores on a quiz or something, and the quiz had 59 questions on it. This says 8 students in the class got a score between 0 and 9 points. But it doesn't tell you what they got. Like, one of them could have gotten a 0, and the other 7 of them could have gotten a 9, right? And then 24 of them got a score between 10 and 19, but it's not telling you if they got a 10 or if they got a 19, or maybe they got an 11, or maybe 3 of them got 11 and 2 of them got 15. Like, I don't know what score they actually got. I just know their score fell in that range. So if you have to find the mean of this is kind of weird, because you're like, well, I don't actually know what scores they got, though I only know what range. So the way we take care of that is you find the midpoint of each of these score ranges. And what we're going to do is we're going to multiply the midpoint times the frequency. We're going to use that as the value. So we're going to make another column. I'm just going to extend my lines over. And this is going to be my midpoint column. So I need the midpoint between 0 and 9. That's going to be 4.5. And then I need the midpoint between 10 and 19. It's going to be 14.5. And then I need the midpoint between 20 and 29. That's going to be 24.5. The midpoint between 30 and 39, that's going to be 34.5. Midpoint between 40 and 49 is going to be 44.5. And our last midpoint is going to be 54.5. Why are we taking the midpoint? We're taking the midpoint because if we average this score and multiply it by the frequency, that's going to make up for whatever the individual values were going to be. So the frequency says how many of them. We're going to do 8 times that 4.5. 8 times 4.5 gives us 36. Let's see. Frequency times midpoint. Okay, so I'm going to put 36 here. Then I'm going to do 24 times 14.5. That gives me 348. Then I'm going to do 19 times 24.5. That gives me 465.5. I'm going to do 27 times 34.5. That's 931.5. We got 2 more to do. I'm going to do 11 times 44.5. 489.5. And our last one, 8 times 54.5. Comes out to be 436. Okay. So I did the frequency times the midpoint for each of these. And so what I want to do now, I have this times this to give me kind of like all the people's scores. So all 8 of those people's scores, I'm just putting those together. And then all 24 of those people's scores, I'm putting those together. And the way we're putting them together is we're doing an average. We don't know exactly what they got, so we're using an average. So ultimately, when we go through, I'm going to take all of these and add them up. But I got to divide them by the number of people. Where am I going to get that from? The frequencies. So we're going to need to go 8 plus 24 plus 19 plus 27 plus 11 plus 8 to get how many people we need to divide by. So I need to add all these up, and then I need to add up all the frequencies as well. So if you look at the formula she gave you, they've got the summations on there. It's because she's saying we're going to have to add them all up. That's the summation part. So I'm going to do 36 plus 348 plus 465.5 plus 931.5 plus 489.5 plus 436 is equal to my total of 2,706.5. But then the other thing I need to add up is the frequency. I need to get my total number of people. So I'm going to add up 8 plus 24 plus 19 plus 27 plus 11 plus 8. So my total number of people is 97. Okay. So if I want an average now, I need to take this number and then divide it by the number of people. So we're going to take my mean is equal to 2706.5 divided by 97. And we get 27.9. And if we think about that, 27.9 is supposed to be the mean or the average score for all the people in this class. There's 97 people in this class. And we can see that if you look at like where the bulk of the people are, like this isn't very many people, but like from here to here is most of the people. And those scores are between 10 and 39. And if you average those together, that should come out to be about 27.9. So this seems like a reasonable answer. It seems like where the data should fall. Question?
I'm sorry, can you just explain how you get to find them?
To find the midpoint, yeah. So to find the midpoint, I need the exact middle number between 0 and 9. Now, a way you can do the exact middle number, if you're like, how'd you do that, Jen? You can take 9 minus 0, which is still 9, and cut it in half. Half of 9 is 4.5, okay? Then you can take 19 minus 10, that's 9. Half of 9 is again gonna be 4.5, but now we gotta add that 4.5 to the lower number. What's 10 plus 4.5? 14.5. And if you do this one, 29 minus 20, that's still 9, right? Half of 9 is still 4.5, but you're gonna add the 4.5 to the 20 this time. So basically, you're gonna add 4.5 to the starting number of each of those groups. So that's why it's 24.5, 34.5, 44.5. All we did was add 4.5 to the starting number of each of those groups. Good question. 9 divided by 2. Yep. Is that okay? All right. I feel as though I've tortured you with enough math today. You did a good job. I'm going to go ahead. I'm going to scan in all these notes and I'll post them into the Canvas so you have those also to look at a little bit later. I'll see you on Thursday.